I want to factorize this by two methods. And I know that this one has 5 roots. Also, I know that one of them is a -1. That means if I have 5 roots over this unicircle, one of them is a -1. This is -1, is a root of this polynomial because when x equals -1, it's a 0. So -1 is a root. The other 4 are complex and are distributed over this unicircle evenly, and each of them is 2 pi over 5 apart. From here to here, 2 pi over 5, 2 pi over 5, 2 pi over 5, 2 pi, and so on. So it has a 1 real and 4 complex roots. So this one must be equal to x plus 1 is a factor because -1 is a root. The other 4, just simply divide this one by x plus 1. You get x fourth minus x cubed plus x2 minus x1 plus 1. Okay, so we are continue factorizing this. Okay, that is I'm using the first method. Is that this must be equal to x squared plus ax plus 1 times x squared plus bx plus 1. Because the complex roots coming from irreducible quadratic factors, and while the real roots coming from the linear factors. And then we compare the coefficients to find a and b, right? We know that by comparing the x cubed and 8 times x, a and b times this one plus b is equal to -1. Then we compare the coefficients for x squared. So this one times this one is x squared. This one times this one is x squared. And a times b is a square equal to 1. So this means that AB equals -1. Huh? Just cancel as a -1, yeah. Okay, and by comparing the coefficients for x, and also we get b times a times ax times 1, bx times 1, so a plus b is equal to -1. Okay, from these 3 equations, these two are the same, so I have eventually I have a 2 integral, two equations, this one and that one. Okay, from these two I can find a and b. Right, a is equal to 2 negative 1 plus root 5. B is equal to -1 plus. Well, I think it's easy to find these a, b from the simultaneous equation, right? So my polynomial now can be factored as x plus 1, x squared minus 2, 1 plus root 5, x, that is a, plus 1, and x squared minus 2, this x1 is root 5, x plus 1. Good. So finally I factorized this. Let's use the first method. Now the second method I use in different way, okay? Second method is this. The first factor is this, because this is a one root. And now on this angle is a pi over 5. This angle is a 3 pi over 5, because 2 pi over 5 are wave. And this is its conjugate, negative 3 pi over 5. This is a negative pi over 5. So these are 5 roots, and x minus the root will be factor. Okay, negative 1 is a root, therefore x minus negative 1 is a factor. And for this, I just x minus this root, this one is a cosine pi over 5 plus I sine pi over 5, right? Yeah, that is a factor coming from this root. And for this one is x minus cosine 5 pi over 5 minus I sine pi over 5. That is second. This is the third factor, which is coming from this root. Then for that one is x minus cosine 3 pi over 5 plus I sine 3 pi over 5. And the last factor is coming from this root, which is x minus cosine 3 pi over 5 minus I sine 3 pi over 5. Well, these are 5 roots coming from x minus the roots respectively. Now then, these two, x minus cosine minus I sine 5 pi, multiplied by x minus cosine plus that one. So we are using the formula a minus b times a plus b is a squared minus b squared. So this will be x minus cosine 5 pi, 5th pi square minus this is square. This is square. I square is positive 1, therefore plus sine. Okay, that means this is square. For these two, x minus cosine 3 pi over 5 square minus this is square. This is square. I square is in positive negative 1, so plus this. 3 pi over 5. Yeah, this is equal to x plus 1. And this would be x squared minus 2 cosine pi over 5. This square plus this square is 1. And x squared minus 2 cosine 3 pi over 5. This square plus that square is equal to 1. So we're left just to find these two, then we get the factors, right? Now, we know that 2 cosine pi over 5 is a golden ratio, which is equal to 1 plus root 5 over 2. I'll prove it later, okay? So this is golden ratio. And for cosine 3 pi over 5 is equal to negative cosine 2 pi over 5, right? That means pi minus that. And this one is equal to negative, we have a formula, well, which is equal to 2 cosine square pi over 2, 5 minus 1. Well, do we have this formula? Yes. Let me verify. Okay, cosine square theta is equal to half 1 plus cosine 2 theta. Therefore, cosine 2 theta is equal to 2 cosine square theta minus 1. Yeah, this negative, this one is 2 times this one. Yeah, it's correct. And then we put this value here, right? We can find cosine 3 pi over 2. Yeah. So that one is equal to negative, that we equal to x plus 1, x square. This one is go to ratio minus half root 5, x plus 1. I forget x. I forget x there. Okay. Times x squared minus 2. We calculate, I omitted the detailed calculations. That is equal to sorry, 2, 1 minus root 5, x plus 1. Well, excuse me for the writing, but anyhow, knowing this value, we can find that value, right? Through these kind of relations. So we factorized everything second time. Now the leftover this, I have to prove this is true. That is the golden ratio. Okay. Now let me use a triangle to prove that. I want to prove 2 cosine pi over 5 is the golden ratio. I want to prove this. Okay, it's a tough job. Now I'm using triangle, isosceles triangle. Pi over 5 is 36 degrees. Let me use the degrees, for a while because easy to recognize. This will be 72. This is 72. This is isosceles triangle. Then, if I draw angular bisector, this is 36. This is also 36. Then this will be also isosceles triangle, right? If this is x, this will be x. This is isosceles triangle. This is 72. Therefore, this is also x. If this side is a 1, is a unit 1, then this is a 1 minus x for this side. Let me use this side is 1 minus x. And also we know that this triangle and this triangle are similar triangles because each angles, corresponding angles are equal. 36, 72, 72, 36, 72, 72. Therefore, all the sides are proportional. So 1 over x, 1 to this 1, will be equal to x to this. This one similar to that one. Therefore, this over this is equal to this over that. And from which we can find x. Very simple. This is okay. This is a solution to this equation. Now, we are looking for that, right? We are looking for 2 cosine 36 degrees, which is equal to 2 cosine pi over 5. We are looking for. Now, that one, well, if we draw a line here, because this is isosceles triangle, therefore, this perpendicular, this altitude, will divide this one into half and a half, right? This will be half. Because this is 1. This is the midpoint. Therefore, cosine 36 degree is equal to 1/2 over x. Here, adjacent side over the hypotenuse. This is equal to 1/2 times reciprocal of cosine. This is reciprocal of cosine. 2 cancel out. And this is root 5 minus 1. I multiply root 5 plus 1. Root 5 plus 1. So this will be equal to root 5 plus 1. This will be 5 minus 1. Right? Yeah. That's, wait a minute. This is 5 minus 1 is 4. Yeah. Where is that two? Okay. I'm missing that two, 2 in the beginning. Yeah. 2 times this one. This one is the root 2 over this one, okay? So I have a missing 2 here. So let's end up with 2, 1 plus root 5. Wow. Excuse me, forget a 2 here. This is a 2 here, okay. All right, so we prove that this is true. Cosine pi over 5 times 2 is the golden ratio. Therefore, all the proofs here, the steps here making sense. Well, I hope you, I hope you can trace back all the details, and hope you like it. Thank you.